Today, we're back with our buddy Hugh Ross on episode 3 of the John Ankerberg Show, aka The Argument from Astronomy. Now, even though this is episode 3, it's also subtitled 21st Century Discoveries Part 1. Ostensibly Part 2 will be the next episode. We'll have to see. Now, for those of you who haven't seen the previous videos, which I'll link, I'll just make a playlist for them at this point, and I'll link to it here. TLDR, Hugh Ross is a actual PhD astrophysicist. However, he only practiced for about 5 years before he discovered that being an apologist pays a lot better. Nonetheless, it's fun to talk about science things, and it's fun to dunk on apologists, so we're going to get right into it. But first, if you're new here, please take a moment to hit that subscribe button. It helps a new channel like this out a lot, and I greatly appreciate it. Now, without further ado, let's hit it.
Today on the John Ankerberg Show, on April 24th, 1992, newspapers around the world heralded the breakthrough news that the COBE satellite gave scientists convincing proof that the cosmic background radiation of the universe proved that the Big Bang model of the universe was true.
That's correct. That was, well, it was announced the day before, but the newspapers came out the following day, and it was huge news. Now, you may recall from high school science that Penzias and Wilson discovered the weird signal that turned out to be the cosmic microwave background back in the 60s. But we had a heck of a time getting really good measurements from down here on Earth, and we tried. We built special receivers, we put instruments in hot air balloons, we did everything we could think of. But all we got was that same solid signal. So in 1989, we launched the Cosmic Background Explorer satellite to find out for sure, and it took years to gather the data, and then when they announced that they had found those tiny little temperature discrepancies, it was huge news.
Theoretical physicist Stephen Hawking said, "It is the discovery of the century, if not of all time."
If I were going to pick the discovery of the 20th century, I'd have to give it to Edwin Hubble, because he proved that there were other galaxies beyond the Milky Way, and never in human history had a single discovery expanded our awareness of the cosmos around us by so many orders of magnitude in one go. That man effectively gave us the universe.
Welcome to our program. I'm John Ankerberg, and my guest today is a very special guest. He's astronomer and astrophysicist, Dr. Hugh Ross. Today I want to start with a discovery that came out April 24th, 1992. And it had to do with the COBE satellite and what they had found concerning the hot Big Bang creation event via the COBE satellite.
Oh, again with the creation of... Well, I suppose we should expect that by now.
Explain what all that means, Hugh.
Well, the early measurements on the universe, attempts to measure the temperature of the universe, they determined it had exactly the right temperature that the Big Bang creation model would predict. However, that Big Bang creation model also predicted that if you were to measure the temperature of the cosmic microwave background radiation to a high degree of precision, you will see hot spots interspersed with cold spots, where the hot and cold spots are a certain angular size.
We already knew the background was there. What we needed to find was those hot and cold spots that Hugh mentioned. And because it was so homogeneous, it was proving kind of difficult. We were starting to have doubts if our prediction was correct.
And I remember at that time, astronomers around the world were sitting on their seats in anticipation. Is the Big Bang going to be proven right or proven wrong?
That's the thing, is there was some doubt about the prediction, but not the Big Bang. Because again, none of the competing models ever predicted a cosmic microwave background. It was a verified prediction. It backed up the Big Bang. But without those hot and cold spots, that makes it very, very difficult to explain galaxy formation.
The initial results came back, and indeed they found the temperature fluctuations of just the right level with just the right angular dimensions. And so that got publicized all around the world, convincing proof of this Big Bang.
There were people that did research that led up to figuring out that there was such a thing as the Big Bang. Give me a few of them.
Well, Vesto Slipher back in 1912 was the first astronomer to discover that the more distant the galaxy, the faster it moves away from us.
Slipher discovered that there was redshift in some of what were then believed to be nebulae within the Milky Way, which Hubble later proved were separate galaxies at much greater distances. They could not be part of the Milky Way because they were so very distant. Some of them had much greater redshift than others, and it was a big puzzle until Hubble provided the missing piece.
And he was followed by Edwin Hubble, and he was able to measure several dozen galaxies to much higher precision than what Slipher was able to do?
Well, first, he measured a Cepheid variable star in Andromeda and proved that it was more than 10 times further away than the entire size of the Milky Way galaxy, which meant Andromeda was not a nebula, but a galaxy in its own right. He then went on to measure other nebulae and discovered they were even more distant. And from that point, he could measure the redshift with greater precision.
Published in 1929 a paper which said, here are the observations proving that the universe indeed is expanding.
And that's not quite accurate either. Hubble published a paper showing that there's a relationship between redshift and distance. That is to say, the more distant a galaxy, the greater its redshift. We did not know that the redshift corresponded to motion.
But that's something that actually flowed out of the equations of general relativity that Einstein published back in 1916.
General relativity predicted that any finite universe has to be either expanding or contracting. Technically, Einstein said it has to be contracting because he could only think of gravity being a force. It was later discoveries that made people think, oh, maybe it's not just contracting under gravity. Maybe there's a reason we could reverse that and have it expand instead.
George Lemaitre, who took those equations of general relativity and said, this establishes not only does the universe have a beginning, it must be expanding from the beginning.
And it's also very important to note, a lot of people conflate the Big Bang with Genesis, as they started to do at this beginning of the show. Lemaitre himself confronted the Pope, who made the same connection, and said, no, this is not that. Don't you dare say that.
Tell them how they found this out, that the galaxies were rolling away from us.
Now he's going to explain redshift, and I'll give Dr. Ross a chance to do it before. If he gets it right, great.
Well, they used a prism in order to see the spectral lines that were being emitted or absorbed by these distant galaxies. And what they noticed is that these spectral lines were being shifted to the red end of the spectrum. That's the Doppler effect. So, for example, when a train goes by a train station, you notice you hear a high-frequency sound as it approaches, a lower-frequency sound as it moves away. That's the Doppler effect. And we saw the same thing in the spectra of these galaxies, indicating that indeed, the more distant the galaxy, the farther towards the red end of the spectrum the spectral lines were shifted.
That's close enough to true for government work. There's one important point that he didn't really cover. When light passes any substance, whether it's oxygen or hydrogen or whatever, that substance always absorbs the light at a specific wavelength or multiple wavelengths. When light from a distant star passes a hydrogen cloud, it will leave hydrogen lines in the spectrum of that light. And we can detect that, and we can say, oh, behold, there's hydrogen between us and that star. It's like a fingerprint for the elements. So when we read a spectrum from a distant galaxy, and we see the fingerprints of hydrogen and oxygen in the spectrum, but they're way over here, we know the spectrum has shifted towards the red.
But I want to talk about, what is the cosmological constant?
The The cosmological constant is something that Einstein put into his equations to eliminate the expansion.
Incorrect. Einstein's equation said that the universe has to be dynamic. A finite universe should collapse under the force of gravity. Lemaitre showed it could expand also if we reverse the direction of time for some reason. We still don't actually have a good reason for that, but that's not important right now. So that was the cosmological constant. It was a placeholder he included into his equations so that they no longer predicted that the universe would collapse under its own gravity.
He was raised in an era of what's called the infinite Newtonian universe.
And he wanted it that way.
And so he wanted to be consistent with that. But in order to get rid of the expansion that his equations predicted...
No, that's not true. His equations predicted a collapse under the force of gravity. It wasn't a matter of wanting the universe to be eternal because of Newton's formulas or anything like that. It was without the cosmological constant, the equations would predict the universe would collapse virtually immediately after its formation. In any finite universe, no matter how big, it's all going to get pulled into the center. It's going to collapse. It had nothing to do with wanting an eternal universe. How dare you?
He put in an additional term that counterbalanced the expansion so that the universe would be stable, not expanding, not contracting.
The universe is static. What does that mean? What does that do for the non-Christian scientists that are out there?
Well, today we know a static universe is a universe that would not permit the existence of life.
Well, no, we don't know that. We only have the universe that we have to work from. It could very well have been. Dr. Ross himself studied quasars. It was theorized for a long time that they were the other end of black holes, that matter fell into a black hole and then emerged from a white hole, possibly a quasar, recycled and refreshed with new energy to keep the universe rolling along.
But back at the beginning of the 20th century, that was not yet understood.
They thought that evolution could have enough time to slowly develop and...
Well, that was something that Einstein's friend, the famous British mathematical physicist Sir Arthur Eddington said. He said if it's according to Einstein's theory of general relativity and according to what Hubble has measured for the expansion of the universe, that only allows the universe to be a few billion years old. And a few billion is not enough time to sustain Darwinian evolution. And that's when there is a...
Let me check on that. I can't find a quote or anything similar to it anywhere. I'm going to need a source for that. I'm not going to say that they went and made it up, but...
Major debate going on amongst astronomers. Is the universe quadrillions of years old or only billions of years old? And today we know the young universe astronomers won out.
Well, in the early part of the 20th century, through the middle of the 20th century, we were constantly moving the age of the universe back because first we thought it was maybe 1 billion or 2 years old. That seemed unfathomably old, but then geologists discovered the Earth was 4.5 billion years old. Well, it couldn't be that the Earth was older than the universe it was in, so we moved the age of the universe back to 5 or 6-ish billion years. And then we started discovering stars that were 8 or 9 billion years old, and well, it couldn't be that the stars were older than the universe they were in, so we moved the age of the universe back. And so on and so on and so on, until we eventually got to the point where we honed it down to about 14 billion years, and then we started getting data on the farthest galaxies on the cosmic microwave background, and we could hone it down to a more precise, more accurate 13.7, 13.8 billion years. And then the James Webb Telescope came along and showed us galaxies that are older than the universe they're supposed to be in. So, we're back in the let's rework the numbers phase again. But the point is that the scientific consensus was not for a young universe. It's been pushing it back to an older and older universe with each new discovery as long as we've been doing this. So, from an honest perspective, no, the young universe interpretation did not win.
It's only billions. It's not quadrillions. That's way too little time for naturalistic evolution to be a viable explanation for the history of life.
I don't know where he's getting that. First of all, an astrophysicist has no business making sweeping declarations about a completely different field like evolutionary biology. Second of all, no astrophysicist says that. When we understand evolution, we understand that it is entirely possible. There's no special expertise in astronomy that tells you how long evolution should take. He's pulling that completely out of his ass.
Let's jump to another person that everybody knows, and that's Stephen Hawking.
Well, he had some help. George Ellis in South Africa and Roger Penrose at Cambridge and Stephen at Cambridge. And it was in 1970 that Roger Penrose and Stephen Hawking published the first of the space-time theorems. They're based on two fundamental assumptions. Number one, that the universe contains mass. The second assumption, general relativity reliably describes the movements of bodies in the universe. If those two things are correct, not only does the universe have a beginning, even space and time have a beginning. Space and time must be created.
No. Hawking and Penrose, first of all, those two things were already known. Hawking and Penrose elaborated on them. They showed with greater precision what was going on based on general relativity, and they provided some more predictions so that we could test and further refine our formulas. And what those improved calculations indicated is that under the right conditions, a singularity can form, what we now call a black hole. It was a titanic achievement at the time, a triumph of mathematics. At no point did they prove or even suggest that space and time must be created. That is absolute bunk. However, fun fact, if you define a black hole as a singularity, a point of infinite density occupying zero space, then you have to go to Hawking and Penrose. But if you define a black hole as a space where the gravity is so intense that light itself cannot escape, that was predicted in 1783. Rather good bit before Einstein himself. That was John Mitchell, an Englishman, who was pondering the concept of how some stars are bigger and heavier, and could it be possible to have a star so big and so heavy that we never saw its light because even the light couldn't escape.
What is a singularity?
It's when the entire universe gets compressed into an infinitesimally small volume. And that volume actually has 10 space-time dimensions. So
now we're back on superstring theory. So he's talking about the cosmic singularity, which is not the same as the black hole kind of singularity, which is infinite density occupying zero volume, but existing in normal space-time. The cosmic singularity, that's a whole other thing. That's all of space and all of time compressed to a point of zero volume. But that 10 dimensions business, that's from superstring theory, which, as I mentioned in previous episodes, is an attempt to reconcile general relativity with quantum theory, but it doesn't actually work. So it's very misleading to say that the space in that non-space space actually has 10 spatial dimensions. We don't know that. We don't have any reason to think so. It's hypothesized by one family of theories that don't actually work.
What about that very early era, the first 10 millionth of a trillionth of a trillionth of a trillionth of a second? That's when we'd expect quantum mechanics to play a significant role.
Well, that's more about size rather than the presence of matter, because of course quantum effects can only affect incredibly tiny distances, for the most part. There are a few exceptions, but as a general rule, very, very tiny distances.
Maybe quantum gravity actually permits a loophole where we don't have a beginning to the universe. However, for that loophole to be valid, the quantum space-time fluctuations during that era have to be quite large. Now, we haven't explored the entirety of the quantum gravity era, As many physicists have pointed out, to get a complete picture, we need a particle accelerator from here to the most distant quasar, which is not going to be financed anytime soon.
Hey, good news. Turns out the most distant quasar is a particle accelerator. Hey.
What does that tell you about how the God of the Bible, the creator of the universe, was the great designer?
There's a non sequitur for you.
Are they able to tell the differences yet?
Oh, the differences. Can we tell from how the universe is assembled, whether it was built by Yahweh or Allah or Vishnu or Odin? Is there a signature on those blueprints so we can determine if we're all worshiping the right God?
What I'm seeing happening amongst my peers is that...
Peers, he says. As we've noted repeatedly, he's been an apologist. That is his profession for the majority of his life. He worked in astrophysics for 5 years, and then he hung it up to go preach and sell books.
100% of the observational and experimental measurements that we can make on the universe, 100% of it testifies there must be a God that created the universe.
100% false. Absolutely none of the observational and experimental measurements have anything to say on the matter of any God, let alone any specific God.
And designed the universe and all of its components so that we humans can exist.
Also, absolutely untrue. If the universe were designed for humans to exist, we would see a lot more humans in a lot more places. As Amy Newman put it recently, it seems more like this universe is designed for black holes than humans.
What I see the atheists doing is they're appealing to things that we can't know.
Oh, the atheists are appealing to things that we can't know. Mr. Every observation proves a God. Okay.
To those parts of the universe we're not able to explore or make any measurements.
Yes, the gaps where God is hiding. It's the atheists that are appealing to God in those gaps. Sure.
They're speculating based on what we don't know. Maybe there's some escape hatch.
Ooh, pot, meat, kettle.
The very fact that they're forced to appeal the non-empirical arguments for their atheism.
At what point have I made any non-empirical arguments? At what point have any of your arguments for God been anything other than non-empirical? You point to data, and then you say, see, this proves invisible sky wizard. But how? There's no connection between those things. The fact we can get reliable, repeatable data kind of disproves God as you understand it, because it shows every time we get reliable, repeatable data, every time an observation is confirmed, it pushes that idea of a supernatural being that interferes with the cosmos further and further and further into the shadows of myth. Atheists appeal to non-empirical arguments. For goodness sake.
Tells me how weak their atheistic position must be.
Okay, let's correct that. The fact that theists are forced to appeal to non-empirical arguments for their theism indicates how weak the theistic position must be. That's an honest statement. Atheism doesn't have to appeal to non-empirical nonsense. What are you talking about?
And also, as we astronomers begin to press back on the frontiers of ignorance.
I wish you would rejoin us astronomers in pushing back on ignorance, instead of being on the other side promoting it.
As we push back, it's revealing more and more evidence for the God of the Bible.
Such as?
The atheists are being pushed into a smaller and smaller corner of speculation about what we don't know.
We have the universe that we're in, and everything that you can measure and look at here points toward a creator.
You know what? If you can't beat him, join him. You're right. Everything in the universe points toward nil. the great not God and creator of creator gods. How could creation exist if not for Nil creating the creator gods to create the universe? There is no other explanation, because by definition, Nil is the creator of creator gods. You can't have creation without a creator god. Of course, Nil immediately devours the creator gods upon completion of their work, but that's neither here nor there. It's proof that it happened. And I'm glad you agree. Everything in the universe that can be observed and measured points towards a creator, which means Nil created the creator and then immediately devoured them once creation was finished.
I see an inconsistency. Everywhere else in their life, they base their decisions on reality and what they can see and measure and do experiments on.
Okay, with you so far.
Only in this region about God are they appealing to things that we can't say are real.
You're talking about religious people again. That is literally true of theists. They can be perfectly rational people, capable of critical thinking in every other area of their life. But when it comes to God, they turn that section off and they start appealing to things that aren't real, that can't be demonstrated. You're talking about yourself, Dr. Ross. Please stop projecting it onto us.
And moreover, their speculative room is shrinking down smaller and smaller. That should tell you something, that you're on the wrong path.
Yes, it should tell you something. You're on the wrong path.
Well, there's a principle you see described in the Psalms and the book of Job, that the more we learn about nature, the more evidence we'll uncover for the supernatural handiwork of God.
We're starting to transition into the self-promotion phase of the program.
It's based on the fact that I go through the scientific literature every day. There are new discoveries being published that give us more evidence, not less, for the supernatural handiwork of God. I tell my friends who are still skeptical, wait 1 week and see what gets published.
I want to say thank you for joining us. I hope this has been informative to you, and I appreciate your being with us. And I'd like you to just stay tuned, because I have a personal word for you in just a moment.
That's it. Just all of that, and it just winds up being a bunch of assertions that God is obviously true, and everyone who disagrees is hiding in a hole and making shit up. And wow, what a disgrace. What an absolute failure of a scientist to so blatantly project the irrationality of his personal faith onto those who base their decisions and their perceptions on realism, materialism, and empiricism. How dare. And additionally, I want to point out my disappointment that this part 1 discoveries of the 21st century was entirely about the 20th century. But hey, I guess math isn't the apologist's strong suit either, right, Dr. Craig? Well, that's it for today, folks. Thank you guys so much for watching. Thank you for subscribing. A big thank you to our supporters on Patreon. As you know, even established channels depend on community support to produce their best work, and as a smaller, newer channel, we're a long way from monetizing yet, so any support you can provide is greatly appreciated. Thank you. And as always, remember, you don't have to project your nonsense onto a completely different group for which it does not apply, because you are better than religion.